Okay, good morning. Listen now. Yesterday we have discussed about some concept regarding solid state physics, means band theory of solids. The meaning, according to atomic physics, a nucleus is there, electron which is revolving around the nucleus. That electron is having its own energy, The electron, whatever it is revolving around the nucleus, having its own energy. That energy level that it has been written like this. This is the energy level of this electron. Now let us consider a crystal. The crystal is containing huge number of atoms, and every atom is containing its own number of electrons. And each electron, each particular atom, if I'm considering, it is having the different shells electrons. The innermost orbital electrons and outermost orbital electrons, like that, it is said to be existing for all the atoms in a crystal. Now, the electrons, whatever it is revolving around the nucleus in the outermost orbit, is called by the name the valence electron. The electrons which are revolving around the nucleus in the outermost orbit is called by the name the valence electrons. If I'm choosing the valence electrons here, then the valence electrons of one atom and the valence electron of another atom, they are interacting. These two are interacting, and hence this energy level splits up into two closely spaced energy levels. Okay, one energy level, it has been divided into, splits up into two energy levels because of the two interactions. Like this, the third electron is also involving from the third atom. If it is also involving in the interaction, then the one energy level, it has been divided into, splits up into three smallest closely spaced energy levels. Like that, if a crystal is containing a huge number of atoms and all the valence electrons, they are all involving in the interaction, then that one energy level, it has been splits up into huge number of energy levels. These are all very close to each other. All the energy levels, they are all close to each other. This closely packed energy levels is called by the name energy continuum. It is called by the name the energy continuum, or is also called by the name energy band. Energy continuum, or is also called by the name energy band. Now, let us consider if it is due to the valence electrons only. For example, let us consider if it is a germanium crystal or silicon crystal, if you are choosing, then inside the silicon or germanium crystal here, the electron, maybe it is said to be the valence electron of one atom and the valence electron of another atom. If they are interacting with respect to each other, then the energy continuum or energy band or energy, whatever it has been divided into small and closely spaced energy levels, they are called by the name the energy continuum. Due to the valence electrons of different atoms, if I'm considering, such energy band is called by the name valence band. Such energy band is called by the name the valence band. Whereas, let us consider if we are using some amount of thermal energy, heat energy. The crystal, it has been kept in the atmosphere only. Atmosphere is having some amount of the heat energy here, temperature. The temperature, if it is acting on that, the temperature is sufficiently enough to remove the valence electron from that orbit. Then that valence electron, it will move from one atom to another atom. If the valence electron is moving from one atom to another atom, such valence electrons are called by the name. Such valence electrons are called by the name conduction electrons. Such valence electrons are called by the name the conduction electrons. If the electron is present in its own orbit, outermost orbit, is called by the name the valence electron. Using the thermal energy, using the electrical energy, voltage if you are applying, this electron, if it is removed from that orbit and the electron is capable of moving from one atom to another atom within the crystal only, then such electrons are called by the name conduction electrons. Such electrons are called by the name the conduction electrons. Now, due to the conduction one electron and conduction another electron, like that, how many conduction electrons are there? If they are interacting with respect to each other, then whatever the energy band, whatever the energy continuum, if you are getting, that energy band due to the conduction electrons is called by the name conduction band. Therefore, energy band can be divided into two categories. One energy band due to the valence electrons, called by the name the valence band. Another energy band, it is due to the conduction electrons. That due to the conduction electron, whatever the energy band we got is called by the name conduction band. Hence, the energy band can be divided into two categories. Energy band can be divided into two categories. One is the valence band, the other one is a conduction band. Valence band, it is energy band due to the valence electrons. The interaction of all the valence electrons, whatever it is closely packed up inside a crystal is called by the name that energy band is called by the name the valence band. And the energy band or the energy continuum due to the conduction electrons, due to the thermal energy or electrical energy, due to that one, if the electron is removed from that orbit and it is capable of moving from atom to atom, is called by the name the conduction electrons. The conduction electrons, they are involving in the interaction, and due to that interaction, the energy level of conduction electron is going to get divided into closely spaced energy levels here. That energy continuum or energy band due to the conduction electrons is called by the name conduction band. Therefore, there are two types of energy bands: valence band, conduction band. Two types of energy band. One is the valence band, the other one is the conduction band. Now the question is, valence band energy, conduction band energy, which energy is more? Valence band energy, usually it is less. I told you yesterday, valence band is just like SSLC students, who they are all attached to the schools still. Whereas conduction electrons means the valence electrons are removed from that orbit. From the school, they have been removed, means they have passed out. Once they are passed out, they are moving to the other college. Other college they are going. Now the knowledge of a PUC student, hopefully I can say, the knowledge of a PUC student is more than the knowledge of a SSLC student. This is usual thing. Okay, therefore, valence electron energy is less. Conduction electron energy is more. Therefore, I can say conduction band is having the more energy. Valence band is having the lesser energy. The valence band is having the lesser energy. Conduction band is having the more energy, because conduction electrons that we are getting due to the conduction electrons we are getting due to the removal of electrons only. Electrons were removed and hence we are getting the conduction electrons. Therefore, conduction band energy is more and the valence band energy is less. Valence band is having the lesser energy. Conduction band is having more energy. This is a concept that we are supposed to remember. Up to here, yesterday it has been finished. Now, today's concept, continuation. Today's concept, what is that? Okay, first concept. Band theory of solids. We are asking for about 3 marks question now. Up to here, whatever I explained, we may ask anywhere else 1 mark questions. Okay, it is the question. What we are asking is said to be explain the metals, insulators, and the semiconductors on the basis of band theory of solids. The question we are framing: explain the metals, means conductors, insulators, and semiconductors on the basis of band theory. On the basis of this valence band, conduction band, we have to explain. Okay, now listen now. This carries 3 marks, easy concept, easy question, and answer is also very easy to answer that. Okay, any material, substance, the materials, it can be divided into 3 categories. One is conductors, means easily it can conduct the electricity. Easily it can conduct the heat energy. Usually we are considering that one as the metals. Metals are good conductors of electricity. Metals are good conductors of heat energy. Okay. Materials or the substance can be divided in the form of, if they are good conductors, we can write even the bad conductors. They are called by the name insulators. Perfectly bad conductors, 100% bad conductors. Insulator, which is not conducting. Electricity is not conducting in the insulator. Okay. Third one, in between case. It is not a good conductor. It is not a good insulator, in between case. So I can consider that one as semiconductor. Semiconductor. It is a type of conductor only. It is a semiconductor. Semiconductor. With some condition, it can act as a conductor. With some condition, it is acting as an insulator. So these three we are supposed to analyze today's class. Explain, okay, or a distinction between, or I can say write the differences between conductors, semiconductors, and insulators on the basis of band theory of solids. Okay, what is that? So first idea, for conductors, I will going to write it here. Just you see here. This is for the conductors I am writing. Here I am writing for the semiconductors. Okay, here I will going to write for insulator. Okay, insulators. What is that? How we are going to define? Now let us consider valence band here. Now I am writing a valence band here. This is valence band. Understand clearly all the points you are supposed to write at the time of examination. Like this, we are plotting the energy. Energy we are plotting like this. Y-axis we are putting the energy. I told you already, energy of the valence band is less. Energy of the conduction band is above this. Because energy of the conduction band is more, energy of the valence band is less. This is valence band. Shall I write VB? VB representing for valence band. This is valence band. I will write, if you want, I will maybe some amount of what is that? Some marking that I will going to put it here. There is a marking that I am putting for the valence band. This is valence band. Okay, this valence band is completely filled. This valence band is completely filled or partially filled. Valence band either completely filled or partially filled at 0 Kelvin, don't forget. So I told you here little bit changes I will going to do it for the conductors. I told you energy band can be divided into two categories. One is the valence band, the other one is conduction band. Valence band energy is less, conduction band energy is more. Valence band at 0 Kelvin, imagine, valence band not at 0 degree centigrade. 0 degree centigrade is different, 0 Kelvin is different. 0 Kelvin means minus 273 degrees centigrade. At 0 Kelvin, valence band may be partially filled or completely filled. Valence band partially filled or completely filled at 0 Kelvin. Whereas conduction band at room temperature, maybe it is partially filled or maybe completely empty. Completely empty. At 0 Kelvin, it is completely empty. Conduction band at 0 Kelvin completely empty. But at room temperature, it may be having some electrons. At room temperature means atmosphere temperature, it is said to be acting here. Electrons are removed from that orbit, hence they are called by the name the conduction electrons. At 0 Kelvin, these electrons are not removed. If the electrons are not removed, no conduction electrons. If no conduction electrons here, then the conduction band, it is not containing any electrons. SSLC exam, they are supposed to conduct. If they don't conduct the examinations of SSLC, then how to fill the PUC students? Now, some of the parents, they are telling that, okay, you should not conduct the SSLC exam. The question is, if you don't conduct the SSLC exam, on what basis we are supposed to take for the first PUC? All the colleges, they are not taking as it is now. Some colleges, they are giving 90% cutoff. Okay, some colleges are giving 80% cutoff, 80% and onwards only that we are taking these students. Otherwise, the students, they are supposed to go to the different colleges and they are supposed to write their own entrance examination, first piece students. Therefore, better to conduct the SSLC examination. Then how to go for ITI? Different combinations are there in ITI, branches are there. SSLC students, they are supposed to go. If all of them they passed out, then to whom we had to give the seats? Problem is there. Problem is there, of course. Now here, this is a valence electron. Valence electron is removed. How it is removed? Using the thermal energy. If there is no thermal energy, means at 0 Kelvin, if I'm choosing, now electrons are not removed. If electrons are not removed, conduction electrons is 0. Therefore, conduction band is containing 0 number of electrons at 0 Kelvin. At minus 273 degrees centigrade, at 0 Kelvin, conduction band is completely empty. Whereas valence band, maybe it is having electrons are completely filled, or it is said to be having little bit number of electrons. Valence band, no problem, at 0 Kelvin. Now coming back to this concept for 3 months. Any material can be divided into 3 categories: conductors or metals, semiconductors, and insulators. Conductors, semiconductors, insulators. There are 3 materials are there now. So energy we are plotting along the y-axis, and the conductors, semiconductors, insulators we are supposed to learn on the basis of band theory. Now valence band is there. Now this valence band, either it is partially filled or completely filled. Valence band in conductors, either it is partially filled or it is completely filled. Then where is the conduction band? Conduction band is attached to this, it is present. This is conduction band. This is conduction band. I will write this is conduction band now. Understand about this? This is conduction band. Up to here, there is a conduction band. Okay. Here to here, there is a overlapping. So valence band is completely different. Conduction band is completely different. It's not like that. If I want to explain with an example, I can quote like this now. Let us consider this is the college. This is the college. Okay. Hostel, it has been attached to the college. Hostel, it has been attached to the college, but not completely inside the college, but attached. Therefore, a hostel student coming to the college is very easy. A hostel student coming to the college is very easy. Where is the hostel? Inside the college campus. Therefore, time taken to move from the college hostel to the classroom is very less. I hope you understood. So here, the college and the hostel, they are overlapping here now. But hostel building is different, college building is different. But they are close to each other. They are having a overlapping here. So meaning is said to be like this. I hope you understood. Let us consider a student who is residing inside the college only. Then time taken by the student to go from that particular place to the classroom is very less. Easily they can move. Easily they can move. This is an overlapped region. This overlapped region between the valence band and the conduction band is occurring. If an electron is present here, you tell me that. If an electron is present here, this is an electron. Where is that electron? Is it in the valence band or is it in the conduction band? It belongs to both. You have already studied about the Venn diagrams in the lower classes. If I'm writing an electron here, the electron belongs to valence band also. The electron belongs to conduction band also. Now, if I'm asking this valence electron, this electron, is it a valence electron? Yes. Is it a conduction electron? Yes, already it is there in the conduction band. That is the meaning. Now, this electron already present in the conduction band, easily it can conduct. Therefore, the energy difference between the valence band and the conduction band is 0. I can consider here energy difference. The difference in the energy is called by the name energy gap. This energy gap is equal to 0. Where it is 0? In the case of conductors. For a conductor, valence band, conduction band, they are overlapped. There is no difference between valence band and the conduction band. Whichever the valence band is said to be existing as an electrons here, they can easily promote it to conduction band. They can easily moving inside the conduction band. They can easily conducting here. the gap between valence band to the conduction band is equal to 0. There is no gap at all. Valence band to the conduction band, the gap is equal to 0. Hence, energy gap between valence band to the conduction band is equal to 0. There is no energy gap is present between the valence band and the conduction band. This is for the conductors, that is for the metals. Because of this one only, if you are taking a copper wire and if you are connecting a battery, maybe it is having 0.1 volt. Just imagine 0.1 volt, very huge, very smallest voltage, that is 0.1 volts. If you are putting here, it starts to conduct. You will get the voltage. 0.1 volt if you are giving here now, then the electron can jump from valence band to the conduction band. It starts to conduct. Possible. Even if you are applying 0.1 volt, even 0.01 volt if you are putting, no problem. Valence electron easily converting in the form of conduction electrons and it starts to conduct here. Therefore, it is a good conductor whose resistance is very less. I can write, if you want, I will write that also. Resistance, not at over, that is under the lower class, maybe 10th standard you have studied about the resistance. The resistance, I will explain this one afterwards. Okay, resistance is very low resistance. Resistivity is also very low resistivity. What is the difference between resistance and resistivity? I will explain under electricity. Okay, next chapter only that I will start that one. Okay, this is a concept. What is that? Conductors are there. In the case of conductors, valence band, conduction band, these two are overlapping, and the valence band already it is having the electrons. It is either partially filled or completely filled, and conduction band is partially filled. If a valence electron is present here now, already it is present in the case of a conduction band. Therefore, electrons in the valence band easily moving into the conduction band. Therefore, I can say energy gap is equal to 0. As the energy gap is 0 and hence the resistance is very low here, resistivity is also very low. Resistance is very low, resistivity is also very low. Okay, this is about the conductors. What about in the case of semiconductors and insulators? Semiconductors, this is the valence band. Easy, provided if you are present for the class. If you are admitting 8:30, 8:45 like that, okay, it is left to you. You cannot understand. Okay, this is valence band. Conduction band is present somewhere else here. This is conduction band. Diagram also you have to write at the time of examination. You have to write the diagram, everything. This is conduction band. Better to write conduction band completely, valence band completely. Don't write VB, CB like that. Okay, I'm writing, but you should not write. You write completely valence band. Band, it is a band theory. Conduction band, you have to write. Here, valence band is completely filled. It's completely filled. Conduction band is empty. It is empty. It is not having any electrons at all. If at all, if you want to promote, okay, SSLC students are there. Okay, unless the SSLC students they passed out, first PUC we cannot make the admission. I hope you understood now. SSLC students, majority, more number of students are passed out, then competition is there for the first PUC seats. Is it clear? So here, valence band is there. Valence band is completely filled. But conduction band is not containing electrons. If at all, if you want to get the conduction electrons here, from valence band to the conduction band, it has to jump. It has to jump. For the jumping purpose, we have to give the energy. We are supposed to supply the energy in the form of what? Thermal energy, heat energy, or in the form of electrical energy, voltage we are supposed to put. Semiconductors are there in your practicals also. You are doing the practicals. Semiconductor diode, forward bias characteristics, you are going to do that. While doing the practicals, you will come to know about this. If you are applying 0.1 volt, electron is jumping here, coming back. 0.2 volts if you are putting, jumping here, coming back. 0.4 volts if you are putting, jumping here and coming back. 0.5 volts if you are putting, jumping here, could not be able to reach the conduction band, returning back. 0.6 volts if you are putting, 0.6 volts. Now 1 or 2 electrons are jumped to the conduction band. It starts conducting. Here is not like that. Here even 0.01 volts if you are putting, easily conducting. But here up to 0.6 volts, electrons could not be able to move to the conduction band. 0.7 volts, more electrons are jumping. 0.8 volts, thousands together electrons are jumping. 0.9 volts, lakhs together electrons are jumping. I hope you understood the concept now. Here to here, there is an energy gap. There is an energy gap. This energy gap is less than 3 eV. Less than 3 eV. Electron volts. 3 eV, less than 3 electron volts is present. Now, if you are giving electrical energy or heat energy sufficiently enough, means more than this energy if we are giving, then the electrons can jump from valence band to the conduction band, starts to conduct. If you are giving lesser than this energy, it is not conducting. Semiconductors are not conducting. Follow this concept. Now, insulators, what is happening here? Okay. Insulators here. This is valence band and this is conduction band. Very simple concept. Valence band, conduction band. What is happening here now? In the case of valence band, completely filled, of course. Electrons are completely filled. Conduction band, it is completely empty. No electrons are present. Now, the energy gap between here to here, this energy gap is more than 3 eV here. Is greater than 3 eV. 6 eV, 8 eV, like that it is said to be existing. It is more than 3 eV. This is less than 3 eV, less than 3 eV, more than 3 eV. Now, valence band is completely filled. Here, if we are giving 0.6 volts, 0.6 volts, valence band electrons are jumped to the conduction band. 0.7 volts, it can jump. Here is not like that. Here, 1 volt if you are putting, electrons are jumping here and coming back. 10 volts if you are putting, electrons are jumping here and returning back. Even 10 volts. Even 25 volts if you are putting, returning back. Okay, this is what is happening in our day-to-day life that we have already come across about this. Whenever if you are doing any, maybe a repair work or something else in that home, electrical repair work, if you are doing something, then we are using the rubber gloves, or maybe we are standing on a wooden plate, which is said to be a good insulator, a dry wooden plate. It is an insulator. At our home, we are having 230 volt supply. 230 volts, imagine 230 volts. As you are standing on a wooden plate with a shoes or something, and having the gloves also with the rubber or maybe the plastic material if you are using, which is said to be an insulator, even 230 volt supply is there, then only 1 or 2 electrons can jump to the conduction band. Therefore, you can feel what is current, but nothing will happen. If at all, if you are removing everything, maybe let us consider rubber gloves are removed. Okay, maybe wooden plate it has been removed, and if you are standing on the ground only, then it is acting as a conductor. 230 volt supply is there, all the valence electrons jump to the conduction band. It is a fatal shock. It is a fatal shock. Therefore, conductors, whenever if we are using in the case of electricity, one must be very careful. Insulator, if you are applying 100 volts, 1 or 2 electrons are jumping. Here, even 0.1 volt if you are putting, electrons are jumping. 100 volts if you are putting, all the electrons are present in the conduction. Here, 0.6 volts is enough to conduct the electricity. Here, 0.6, 10 volts, 25 volts, it is not at all conducting. But 230 volt supply, if you are putting, some electrons are jumping and it starts to conduct. 440 volts, high voltage, 440 volts, if you are applying here, still around about 100 to 200 electrons are jumping and it starts to conduct. But that conduction is very less, very less. Approximately, we can take it as 0. Therefore, insulators are having more energy gap. If it is having more energy gap, if at all, if it wants to conduct here, then the valence electrons jump from valence band to the conduction band. It is somewhat very difficult here. Without that supply of energy, electrons could not be able to jump to the conduction band. Here, lesser energy is required for the valence band electrons to jump to the conduction band. Here, I told you, resistance is very low, resistivity is very low. Whereas in this case here now, resistance is slightly high, around about 2 ohms, 3 ohms like that. Resistivity compared to this one, that is also said to be slightly high. Whereas in this case here, resistance is very high. Don't forget, very low and this is very high. Resistivity is also very high. Resistivity symbol rho, resistance symbol R. Resistance of a conductor is very low. Resistivity of a conductor is very low. Resistance of an insulator is very high. Resistivity of an insulator is also very high. This is a basic difference between conductors, semiconductors, insulators on the basis of energy bands. If they are asking, explain conductors, semiconductors, insulators on the basis of band theory. This is the idea that you are supposed to write. We are asking this question for about 3 marks. I told you already, we are asking for 3 marks. Today I cannot send the notes. Okay, today if possible I will send it. I am having some other work. So tomorrow I will send it. Tomorrow I will send up to here, whatever it has been portions are covered, electronics portion, I will send the notes. Okay, so now if you want to ask the question, you can ask. Tomorrow I can start the other concept. The further concept I supposed to start. Another 3 minutes time is there. Okay, anybody wants to ask the questions, you can. Yes. I have unmuted. Anybody wants to ask the question, you can. Come in time for the classes. We are taking only half an hour also if you are not coming regularly.